Okay, the last thing we want to cover in chapter 6 is actually going the other direction. So we've been doing z transforms on x so that we can get values of z. But now let's say we're given values of z and we want to get values of x from that. So we're going to go the opposite direction in this video. So if you recall, we had our two different transformations and we've been working with z is equal to x minus mu over sigma. And now we're going to use this other formula, which is just x is equal to z sigma plus mu. So to make sense of this, let's go ahead and start with an example. So let's say x represents SAT scores, and we assume that SAT scores are normally distributed. The mean SAT score is 1050, and the standard deviation is 180. So let's say we know someone scored 2 standard deviations above the mean. So what was their SAT score? Well, remember that z-scores represent the number of standard deviations away from the mean. So 2 standard deviations above the mean, so that would mean z is equal to a positive 2, because it's 2 standard deviations above the mean. So now we can apply our formula. So let's just say x is equal to, so our z value is 2, times sigma, where sigma was given to us as 180, plus our average, which was given to us as 1050. So if we plug that in, so 2 times 180 would be 360. 360 plus 1050 would be a score of 1410. So if someone scored 2 standard deviations above the mean, then that means their SAT score was 1410. Let's try another one. We know that someone scored 3 standard deviations below the mean. What was their SAT score? Okay, so z here would now be a -3. Right? 3 standard deviations below the mean. So below the mean would be a z value that is negative. So z is -3. And now we just plug in to our formula again. So x is equal to -3 times our standard deviation of 180 plus 1050. Again, this is just applying this formula up here. X is equal to z sigma plus mu. That's all we're doing here. Recall sigma was 180 and mu was 1050. So I'm just plugging these values into our formula. So z was -3, sigma 180, mu is 1050. So let's see what that works out to be. So -3 times 180 is 540 plus 1050 would be a score of 510. So someone who scored 3 standard deviations below the mean would have had an SAT score of 510. What percentage of people would we expect to score above 1230? Okay, let me give ourselves a little bit of room here. What percentage of people would we expect to score above 1230? So this is actually going in the usual direction where we say z is equal to x minus mu over sigma. So this question is asking what's the probability that, or what percentage of people would have scored above 1230? So x greater than 1230. So now we z transform, so probability that z is greater than 1230 minus our average 1050 over sigma 180. So that's the same as the probability that z is bigger than 1. So the probability that z is bigger than 1 okay, so we're saying we want z bigger than 1, so that would be everything to the right of 1. So that would be our 13.5% plus the 2.5%. So 13.5 plus 2.5 would give us 16. So this would be equal to 13.5 plus 2.5, which is equal to 16. And this is just using the empirical rule. Okay, what percentage of people would we expect to score between 1050 and 1410? Okay, so we would say probability that someone scored between 1050 and 1410 would be the same as probability 1050 minus 1050 over 180 less than z less than 1410 minus 1050 over 180. So this would be probability between 0 and, what is that, 1410 minus 1050 is 360 over 180, so that's going to be 2. So let's use our empirical rule again. Sorry for the scrolling. I hope that doesn't cause a headache. But so between 0 and 2, so from 0 to 2, so that would be this area and this area, right? It would be all of this. So that would be 34% plus our 13.5%. So this is 34 point, or just 34 plus 13.5 is 47.5%. Again, by empirical rule. So these are percents.